Hi everyone, and thanks for joining us today for the CloudBees Connect virtual conference. Today's workshop covers a lot of topics from JVM administration to the top 5 Jenkins issues we see here at CloudBees Support. So let's get started. My name is Ryan Smith, and I'm currently the Global Escalation Manager for CloudBees. I've been with the company for a little over 2 years. I'm formerly a Senior Development Support Engineer within our support organization, and I'm heavily focused on maintaining the performance and stability of Jenkins. I've worked with enterprise Java deployment for a little over a decade, and I'm joined here today by my friend and colleague, Michelle Fogwell. Michelle, tell us a little bit about yourself and kick us off.
Hey everyone, I'm Michelle. I am a current Senior Developer Support Engineer, and I've been at CloudBees for about 3 years now. I started my career as a programmer, but I turned to support because I'm really passionate about the customer experience. And this gives me a chance to see what issues customers are facing in the real world. As we mentioned, we both work at CloudBees, and just to tell you a little bit more about our company, we offer enterprise CI/CD products and services. We have the largest number of Jenkins certified engineers and are proud to be the #1 contributor to the Jenkins project. Next slide. So what are we going to talk about today, and how is it going to help you? Jenkins has changed a lot over the years, and that means so have the best practices. We're going to make sure to talk about the latest best practices, and we'll cover JVM tuning and administration. We're going to talk about the top 5 issues that we as a support organization see our customers struggle with, and we'll go over solutions for those as well. Once we've covered that, we want to show you some real-world data to back up what we're saying and then answer any questions you might have. We're hoping that this information is going to help you with your JVM administration skills and make you care a little more about the inner workings of the JVM and topics like garbage collection. This will help you grow as a Jenkins administrator so that you and any development teams you're working with can have a better Jenkins experience. Our goal is to help you get the most out of Jenkins. Next slide. So let's talk about Jenkins and JVM. Jenkins and JVM are both impressive pieces of software. They run pretty well out of box, and if that's all you're doing, they're pretty simple. The problem comes when you start to need customizations. It starts out with a small change, but as your user base grows organically, so will the level of complexity. With all the possible customizations, we encourage you to do research to make sure you're choosing what's best for your company, or you can always come to CloudBees to get the answers. The CloudBees support team works through thousands of tickets every month. It makes us really good at seeing the big picture, and that helps us point you in the right direction based on your requirements. We also offer professional services to help you set up your CloudBees Jenkins instance if that's where you're at. And just to give you a little spoiler, one of our customers saw a 3,500% increase in their Jenkins performance by implementing a lot of things that we're going to be talking about today. Next slide. And I promise it's not shenanigans, and Ryan's here to help me prove it. Ryan?
Thanks, Michelle. I want to kick off by giving a brief overview of the inner workings of Jenkins. We see thousands of support cases a year at CloudBees, and I find myself repeating this phrase a lot on phone calls with clients. Jenkins is a Java application, mainly because system administrators often forget that with most Java applications, there's a layer of JVM administration that often becomes overlooked after deployment. Common responsibilities of the JVM administrator include defining an initial heap size, setting JVM arguments, but it's not necessarily a set it and forget it role. As usage of the application increases, so does the need to monitor and revisit those initial settings. You're looking at a high-level overview of JVM architecture. The underlying mechanisms like class loader, code compiler, garbage collector, this is all commonly a black box for most Java developers. What you really need to grasp here without understanding all the moving pieces is that the JVM has 2 primary functions. First, to allow Java to run an application on any device or operating system. That's the Java write once, run anywhere principle. Second, to manage and optimize program memory. So how is memory allocated? This illustration sheds some light on that black box from a memory allocation standpoint and uncovers some common misconceptions. The most common misconception is that the memory you allocate to heap space is all the memory the JVM is going to consume. That's simply not true. There's always memory in use from the JVM outside of the heap space. Some of you might be familiar with the concept of permgen space in Java 7. And in Java 8, it's now referred to as metaspace. Metaspace is memory the JVM uses to store class metadata. It's important to understand that metaspace is unbounded by default. So if a class leak is present, you can have an out-of-memory event. In addition to metaspace, there's also Java native memory. This is where mechanisms like garbage collection take place, as well as code generation, which is essentially conversion of bytecode to native code. In short, there's a lot more going on under the covers than you might think. I want to talk just a little bit about one very important mechanism of the JVM, the garbage collector. Garbage collection in many circles is referred to as voodoo science. There's a lot of different garbage collection algorithms out there that do things just a little differently. But to break it down to a simplistic overview, there are essentially three main steps to garbage collection. First, objects get loaded into heap memory. During a garbage collection cycle, the garbage collector iterates through all those objects and determines whether or not they're reachable. If they're not, they are marked for collection. That's what's called the marking phase. Next, during the sweep phase, all the objects that are marked for removal are removed from memory. Lastly, during the compaction phase, all those referenced objects are compacted down, which makes new allocation faster. It's important to get a base understanding of how this works because I'm going to show you later what effect this mechanism has on the overall health of Jenkins. Traditionally, as system admins, we look at these three primary metrics when monitoring a Java application. Primarily, how much CPU is being used and how much memory. I refer to these things as macro metrics. The problem with this is that it's difficult to forecast problems before they happen. So I'd like to suggest the concept of monitoring micrometrics as a good best practice to employ in your environment. So what exactly are micrometrics? Well, in short, some examples of micrometrics are object creation rate, which is essentially the rate of objects that are being loaded into memory. Garbage collection latency, which is how long a garbage collection cycle is taking to complete. For applications like Jenkins with low latency requirements, we want to see that limited to under 1 second. Garbage collection throughput, which is how much time the application is not spending in garbage collection. We like to see this at 99%. The good news is you can gather these micrometrics by analyzing things like garbage collection logs, thread dumps, and heap dumps. Garbage collection logging can be enabled by defining startup parameters for the JVM. Thread dumps and heap dumps can be collected on the fly by issuing commands to the JVM using tools like JCMD, JMap, and those are provided as part of the Java Development Toolkit, or JDK. This is one reason we recommend using a JDK instead of a JRE as one of our best practices. While there are many tools out there for analyzing this data, we recommend GCeasy, FastThread, and Heap Hero. All of these online tools are free, as long as you're not an enterprise client, and allow you to upload your logs directly to their site for analysis. Here at CloudBees, we use an enterprise version of these tools, which allows us to keep the data in-house and secure. Here's a quick example showing the GCeasy interface, which allows you to upload your garbage collection logs directly to their online analyzer. Remember we talked about how garbage collection works with the three cycles, marking, sweeping, and compaction? Well, let's turn this graph on its side for an example. Note the pattern that this creates when objects are loaded into memory and then subsequently get removed. This might look familiar to you if you've ever analyzed a garbage collection log before. We call this the sawtooth pattern. The sawtooth pattern is an indicator of a healthy application. This means that you have allocated enough memory to the JVM so that it has plenty of room for objects to be loaded, removed, and the space compacted to make room for new objects. In an unhealthy garbage collection log, you might see a pattern that looks something like this. Notice that pretty sawtooth pattern disappears and there's now evidence of a memory leak. So why is this important? Why should you as a Jenkins administrator care about this? Well, in short, paying attention to these micrometrics like garbage collection logging will allow you to forecast problems before they happen. Here's an example showing how over time I can see early indications of a problem before an out of memory event occurs that takes down my application and ultimately affects my end users. In this case, I can see the application is suffering from what appears to be a memory leak, and therefore I could take steps to notify my users of an upcoming maintenance window where I could capture heap dumps to further analyze the situation. I had mentioned fast thread earlier as an option to analyze thread dumps. Thread dumps can be taken using JDK tools like JStack, and once you've captured them, you can upload the output to the analyzer. Anytime you need to understand what Jenkins is doing at a certain moment, you can capture a thread dump. A thread dump analysis looks something like this. Note the micrometrics we can gather from this output, like total thread count. In a healthy Jenkins instance, we see thread counts hover anywhere from 200 to 300. In this example, we see a very high thread count, which indicates we may need to look deeper into the individual threads to understand what exactly is going on. In this example, I was diagnosing a slow running instance, which was suffering from a performance issue. Here we see that there's 54 blocked threads with the weather column. While the weather column is a nice feature to have in Jenkins on smaller instances, we don't recommend running it on larger masters that may have thousands of jobs running. The key here is that I would not have known the weather column was the root cause of the reported performance issue unless I had captured that thread dump as a way to investigate it. I'd like to turn it over to Michelle to talk about some of the challenges we often face with Jenkins Administration.
So this video is a great way to illustrate what happens with Jenkins. You create a really solid instance similar to this tire swing, and you start using it. The tire swing is fun, and so your friends want to jump on. Just like when your Jenkins is running smoothly, other teams want to jump aboard. Nothing bad is going to happen at first, but the more people that you add on, the more you start to feel your instance slowing down. If you continue to allow anyone to jump on board without making the necessary adjustments, then you're going to end up holding your breath as it gets slower and slower, just waiting for something to go wrong. After enough teams jump aboard, you'll see that eventually something will go wrong. When talking about the main issues we see our customers have, we can break it down into two categories: people and infrastructure. First, JVM skills are often not a focus when looking at a Jenkins admin. We find that customers use out-of-date best practices and aren't staying current on their knowledge. We also see that growth within Jenkins happens organically. One team has success with Jenkins and the other teams want to do it as well, similar to the tire swing. This is something a lot of people don't account for and becomes an issue if you aren't adjusting as you need. The other thing we see from the people side is that there can be a lot of different sources causing strain, and it's hard to keep track of who's doing what. The other side of Jenkins admin is the actual infrastructure that you've set up. We see a number of disk performance issues due to a lack of optimization. We see poorly managed memory and garbage collection settings, and these things are often overlooked when talking about how to have a healthy Jenkins system. One thing people don't always realize is that calling a REST API over and over can put a strain on the system as well. And the last item worth mentioning is that third-party plugins aren't always your friend. They can add some cool features, but not all of them are worth the strain they're going to put on the system. If you can focus on a few of these things, you're going to save yourself a lot of time in the long run. This is a list for you to look back on that outlines configuration best practices, and I want to touch on a few of these. First, rotating your build history. Make sure you're choosing to keep only the important builds. You don't need to keep all information forever. You also want to make sure you use a JDK and not a JRE. And the NFS versions 3.0 and 4.1 are the recommended versions for performance. G1 is the garbage collector that we recommend, and when you enable logging, it can help you know when you need to grow. You want to explicitly set the heap size because you need to know how much your app requires, and monitoring the macro and micro metrics like Ryan had discussed are really important. You can also install the Support Core plugin, which allows you to easily collect these logs. The last one is a link to the JVM recommended settings for Jenkins, so I highly recommend you read over that. And now we're going to talk a little about scaling horizontally. If you're not familiar with the term scaling horizontally, we mean adding additional resources or masters to allow for the growing user base to continue to use Jenkins as smoothly as you currently have it. So how do you know when it's time to scale? As with most questions, it depends. It mostly has to do with your Jenkins usage and growth rate. You want to stay ahead of the need, but you also don't want to be wasting money with unnecessary resources. Jenkins is memory and I/O bound. This means that you're able to monitor how the system is doing. We highly recommend that you set this up. That gives you a really good idea of when it's time to scale. And you want to avoid huge masters. If you have thousands of jobs, it's time to split up your masters into multiple masters. When splitting up your masters, you want to make sure you're segmenting them logically. A lot of our customers do this by teams, and we actually do recommend one team per master. The only thing that doesn't really depend is that you cannot use more than 16 gig heap. The old school way of thinking about Java development is no longer the best way. It was common knowledge that the JVM needed CPU, RAM, and disk space. When the JVM ran out of memory, you added more. If you ran out of more to add, then you had to convince your boss that you needed to buy more RAM. That was common practice. The problem is that with larger JVM heap sizes, you get larger garbage collection cycles. Garbage collection cycles are stop-the-world events. This means that no other threads are going to execute while garbage collection is taking place. We've found that in order to keep your garbage collection cycles under 1 second, a 16 gig limitation of heap size should be observed. And now we're going to go into the countdown. So we see, these are the top 5 issues that we see in Jenkins, but I first want to touch on how we came up with these. So I already mentioned that Ryan and I's team deals with thousands of cases, and we have access to a lot of diverse Jenkins users. So we pulled Jenkins engineers from different industries and company sizes, and these were the reoccurring themes. So let's start the countdown.
Thanks, Michelle. To start off with number 5, the fifth most common issue we run into within CloudBees Support organization is quite simply a lack of architectural understanding of what Jenkins is and how it works. Not only is Jenkins a powerhouse within your software delivery management system, like I said earlier, Jenkins is a Java application, so that means it requires JVM administration. In addition, Jenkins doesn't have a traditional database associated with it. So it relies on the Jenkins home location, flat file configuration reads and writes, making I/O throughput an important part of the overall infrastructure. We also find that many times admins don't know where to go when they have a question. Some important parts of the infrastructure are networking, storage, Linux administration, Kubernetes administration, to name a few. As a solution, we recommend identifying subject matter experts in these areas, making sure that you have thoroughly documented your infrastructure and understand where Jenkins fits in as a critical piece of your CI/CD pipeline. Lastly, ensuring that you have a playbook for when things go awry and you know who to call. Michelle, take us to number 4.
All right, we often have people reach out saying that their Jenkins is broken while also telling us that nothing has changed. As far as they know, nothing has changed, but Jenkins has so many moving pieces that this change can be happening a number of places. One reason this can happen is miscommunication between teams. This can make it appear that an error came out of nowhere. We see this when a different team updates a plugin without confirming with anyone. We also see pipelines being changed without proper notification to any affected teams. This is one of the reasons we recommend putting your pipeline code into your source code manager as a best practice. You could have network or firewall changes that break your Jenkins, and these can be difficult to find. Someone could do a security upgrade, and if you patch the kernel without testing with your version of Jenkins, that could be another thing that causes error without you realizing. All of these reasons are some type of poor communication between the teams at a company. So what can you do? We recommend taking a scientific approach. And what I mean by that is keeping everything consistent and only making one change at a time. This allows you to know where the error is coming from. It's also a great idea to keep a log of the changes so you can see what's been adjusted recently. You want to increase the communication between teams and ensure that any architectural changes need to be sent out ahead of time for other teams to be prepared. There are plugins you can use to track change logs. And at the bottom of this, we've included 2 links to our recommended plugins, the Job Config History plugin and the Audit Trail plugin. On to number 3.
Thanks, Michelle. So number 3 is going to be having inconsistent backups. And we hear a lot that, quote, we don't have a backup. Surprisingly, one of the top issues we deal with is quite frankly a lack thereof of backups. And most admins have deployed Jenkins and set up backups, or at least they think they did, and they never tested it. And it's a really tough position to be in when catastrophe hits the data center and you find out the backups you've been running smoothly for the last 3 years appear to be 0 kilobytes in size. Believe me, I've been there and it's no fun. Jenkins can be easily configured to perform backups through the backup plugin. But the more important piece here is to understand the ceremony of how to perform a backup and restore of the crucial data Jenkins relies on, which is located in the Jenkins home location. Again, practicing that strategy and checking on your backups frequently to ensure the data is sound is an excellent best practice. Remember that there is no database associated with Jenkins. The Jenkins home location is the data point of record. This will keep you from having tough conversations by not having backups. Take us on to number 2, Michelle.
So we see a lot of teams who use monolithic masters. This means they keep piling all their jobs onto one master, and that is what we call a Jenkinstein. There are a few ways you can tell if you have a Jenkinstein. If you have multiple teams using the same server or a misuse of resources, you might have a Jenkinstein. As we talked about earlier, choosing to follow the old school way of thinking about Java development means you probably have a Jenkinstein. Quick recap, larger JVM heap sizes mean larger garbage collection cycles, which brings your Jenkins instance to a standstill. You want to focus on scaling out to avoid this. With monolithic masters, you have your cowboys and cowgirls going around the Wild West, downloading their favorite Chuck Norris plugin without thinking about the ramifications for the master as a whole. It ends up coming down to there are just too many cooks in the kitchen. When you scale horizontally, you can allow people the freedom to mess things up without a large blast radius when Jenkins goes down. Having 0 downtime isn't a realistic expectation. So the next best thing would be to limit who's affected when one master does go down. There's a great link here about moving to the new way of thinking about JVM administration, which I highly recommend. It includes a lot of best practices. If you take nothing else away from this, remember to scale out and no more than 16 gig heap. Ryan, bring us home.
Thanks, Michelle. The number 1 issue we see in the support organization is that Jenkins becomes slow or unresponsive. And this is the whole reason I walked you through all that JVM and garbage collection stuff earlier. When we on the performance and stability team hear that your Jenkins is running slow, the first place I go to is the garbage collection logs. 9 times out of 10, with a little prescriptive tuning of JVM parameters, we can resolve that slowness. Most of the time, the root cause ends up being that the JVM administrator has simply neglected the JVM since it first got deployed. Now the application usage has increased to a point where it requires more resources than you initially gave it. While garbage collection is often the issue, some other commonalities we see on the front lines of support tend to be around directory services configuration, or maybe running a tier 3 plugin that has some poorly written code. Nothing against the Chuck Norris plugin, which tells you a Chuck Norris joke on demand, but it's probably not something I recommend running in production. The solutions to these issues are simply to follow our best practices around JVM administration, pipeline construction, and to keep an eye on those macro and micro metrics we talked about earlier. By doing these things, you've got a leg up in ensuring you're running a stable and performant Jenkins. I want to change gears here and show you some real-world data examples where we were able to resolve performance issues with some of the best practices that we talked about here today. The scenario here is that it was reported that users were waiting several minutes to log into the application. and UI navigation is painfully slow. Now, when we look at the garbage collection data here, we can see the following KPIs. Notice that the throughput is at 92%. This means that about 8% of the time, the application is waiting for garbage collection. Remember earlier I had said we want to see this number at above 99%. Remember also that garbage collection events are stop the world events, like Michelle noted. So during this time, no other threads are moving, including login and HTTP requests. Ultimately, this is causing a bottleneck that will eventually render the application unusable. Also take a look at the max pause GC time. Do you see that there's 20-second wait times there? This explains the UI slowness reporting, as well as the thread bottlenecks this is causing, because Jenkins is a Java application that requires low latency. If I'm waiting on a GC cycle that's taking 20 seconds, that means that the UI is essentially unavailable for me to log into. When we dig into this further, we notice what JVM arguments are in place. And we found several arguments that were forcing the G1 GC algorithm to work overtime to keep up with the constraints of the argument limitations. Some of the examples of these unwanted arguments are listed here. Take note that these are very explicit arguments that are setting values of percentages and sizes. It's an old school way of thinking to do this for fine tuning the JVM. In fact, I'd call this over tuning the JVM. As the JDK has matured, there's a more keep it simple methodology that comes with it that states allow the JDK to do what it's intended to do and stop throwing a wrench into it when it's trying to do what it's intended to do. For what it's worth, I recommended these arguments about a year ago. And that just shows you that that was a time inside of Java 8 where recommending these arguments was necessary. And like I said, as the JDK has matured, these fine-tuning arguments are no longer necessary. When we remove those arguments, watch what happens. The throughput goes to 99%. And take a look at the number of garbage collections that are actually taking place here. When we compare the data from what we were just looking at, we saw 41,000 garbage collection cycles over a 48-hour period. Compare that to what we're seeing now, and we're only seeing 2,800. Note that max pause GC time actually went down as well, from 20 seconds to one spike of a 3-second interval. On this master that we're working on at an enterprise financial customer with thousands of jobs, this was a huge improvement. Here's another example of real world data from a big shipping company that we worked with. The scenario here was that it was reported that HA failovers were occurring daily, leading to multiple production outages and downtime for Jenkins users. Now looking at this garbage collection data, the following was observed. Note that on the left-hand side, the time is in seconds, and we see several GC pauses that are well above 20 seconds. Well, if my HA failover time is less than 20 seconds, then this means that it's going to initiate an HA failover. When we take a look at some of those JVM arguments that were in there, once again, we see old arguments that at one point in time we had recommended. Also, you'll note that in this chart, you'll see that system.gc method calls were taking place, which are often found in third-tier plugins, as there are no system GC method calls inside the Jenkins code base. This method call essentially calls the garbage collector ad hoc and is throwing a wrench into its natural cycle of taking garbage collection. What we did here was not only remove the unwanted JVM arguments, but we also disabled the explicit GC method calls using an additional JVM argument. What we have here is a 3,500% performance increase when we did that. We went from 12 to 23 seconds to an average GC pause time of 660 milliseconds. On an absolutely monolithic master at this big shipping company, the end users were absolutely raving that instead of having to wait for their application to log in for 20 seconds and walk away and get a coffee, now they're coming logging in, and it's taking less than half a second. This was a huge improvement.
So I wanted to wrap up by telling you a little bit more information about CloudBees and how we help customers get the most out of Jenkins. As a CloudBees customer, you're entitled to CloudBees support. As we mentioned, Ryan and I both work on the support team and work with a fantastic team of Jenkins certified engineers. We're located all around the world, allowing us to provide 24/7 support. We work with thousands of customers, allowing us to see that bigger picture and help guide you to be successful with your Jenkins. Our customers have dedicated success managers who will help you drive your CD plan forward. We also offer online training, which you get free as a customer, and our support team assists with upgrades. I wanted to highlight a little about our training. Customers have access to the online training portal where you can see all of our courses. We have courses focused on pipeline advanced, Jenkins Administration, and if you're interested in getting your Jenkins certification, we even have a study course for that. We offer a knowledge base with documentation about updated industry best practices, and we have a list of plugins certified by CloudBees, so you have the confidence that you're using plugins which have already been tested by a Jenkins engineer. Ryan, do you want to talk about assisted updates?
Yeah, I just want to bring up that some of the best feedback we've had from our current CloudBees customer set has been around the assisted update program. If you've been through a Jenkins update in the past, you know it can cause some anxiety with plugin dependencies and making sure backups are in place and verifying build jobs work after the update, syntax changes that come between versions. With the assisted update program that you get as being a CloudBees customer, the support team here works with you proactively to create a plan of action that makes your update run as smooth as possible. And if you're a platinum subscriber, we offer live assistance during your scheduled update. I also want to tell you about the Jenkins Health Advisor. Whether you are a CloudBees customer or an open source user, if you haven't heard about Jenkins Health Advisor yet, I strongly recommend that after this presentation, you go and download and install this plugin. Our support team is focused around automation and making your life easier. And as a part of that, we wanted to share Advisor with you. Advisor automatically analyzes your Jenkins environment and provides you proactive reporting on potential issues before they get out of hand. It emails you with solutions to discovered issues so that you can prioritize them accordingly. So if you're ready to get the most out of Jenkins, contact sales@cloudbees.com to see how we can help you. We're looking forward to speaking with you. And I've also included some of the resources list that we've talked about here today. I encourage you to click through that. And finally, we're going to go ahead and take some live Q&A with myself and Michelle. Thank you all for enjoying the conference, and I hope you learned something today.
Thanks, everyone.